Well, hey guys, I wanted to give you another look at how they do protocols on the ACT science exam. And in this particular case, we're going to look at one that's a biological protocol. Okay, with that in mind, let's get rolling. So looking at the figure on the far left, notice that it begins with steps 1, 2, and 3. As soon as you see that in the science section of the ACT, read it. Don't ignore it, read it. In this particular case, they give you an illustration of those steps. And this protocol is talking about amino acid mixtures. And notice the word mixture, that means there's more than one amino acid there. And it's sitting, or it has been placed, the mixture has been placed in the middle of what they call a paper strip. That paper strip, both ends are submerged into a solution, and that solution has a certain pH. They apply an electrical source across the paper strip. Notice one end is positive and the other end is negative. Then in illustration 3, they depict the number of amino acids that have migrated out of the mixture or separated out of the mixture. Notice 3 of those amino acids are being attracted to the negative terminal of the battery, while 2 of those amino acids are being attracted to the positive terminal of the battery. Well, what does that say about the charge on the amino acids themselves? Well, if we're still looking at figure 3, illustration 3, figure 1, the 2 amino acids that are migrating towards the positive end have to have a negative charge. And the 3 amino acids that are migrating to the negative end have to have a positive charge. Okay. That's the overall idea. Just keeping with that very basic idea, they're going to perform a series of experiments to get a better idea about the amino acids and some more information about them. Looking at the figure in the middle where it says experiment 1, notice this experiment is divided into 5 trials or 5 different experiments. What is changing in the experiment? Well, the pH is, you got a pH of 10, 9, 6, 5.5, and 4.5. But notice it's only one amino acid. So they're showing us the effect of changing the pH on the amino acid. Now, when the pH is 10 in trial 1, the amino acid takes on a negative charge, so it's attracted to the positive terminal. As the pH changes in trial 2 to 9, notice the amino acid gets closer to the center of the paper strip. So it's becoming less negatively charged. Look at trial 3 with the pH of 6.0. The amino acid ends up in the middle of the paper where it was first placed. When that happens, that means there is no charge on the amino acid. And at that point, we have found the amino acid's isoelectric point, or what we call the pI. So the pI here would be 6 when we have a pH of 6. Trial 4, they make the pH of the solution more acidic. It's 5.5. Now the charge on the amino acid becomes positive and it's attracted to the negative end. Look at trial 5. The pH is 4.5. And the charge on the amino acid is a little bit more positive because it's moving closer to the negative terminal of the battery. Okay. The most important point here is realizing the effects that the pH has on the amino acid. Moving to figure 3, we see there are 4 more experiments. Trial 6, 7, 8, 9. This time, they've got a mixture of amino acids. In trial 6, the pH is 5. 3 of those will have a positive charge of a pH of 5, and 1 of them will take on a negative charge. Trial 7, pH of 5. It affects these 2 amino acids differently. It makes 1 of them very positive, so it's very close to the end of the paper strip, and it makes the other one slightly negative. Trial 8, a pH of 4. We've found the isoelectric point of 1 of the amino acids, which would be 4, but the other 3 are positively charged. Trial 9. There were 2 amino acids here. One of them is going to be positively charged. The other one's going to be negatively charged when the pH is 9.5. So they've clearly showed you how changing pH affects the charge on the amino acid. And anytime you encounter a protocol where there's steps describing how to do the experiment, such as in figure 1, step 1, 2, and 3, you must always read it. Now notice I didn't read the paragraph in the middle figure at all. I just went directly to the data. I hope that you can get to the point where you don't need to read some of this information. You can just go to the data, look at what the data is telling you, understand it, and then move to the questions. Okay, I hope this has helped you. And if we can ever be a help to you, please reach out to us. And I'll always get back to you. Have a great day.